is both a bioinformatician and a biologist, so she really understands biological knowledge and how to structure it into forms that can be queried over and reasoned with. And so,
okay, cool.
yeah, so
Yes,
she'll be one of the curators for this project.
Perfect. Welcome on the board. Okay, maybe I start with a small introduction once again. So good evening, good morning, everyone. Today we would like to discuss three things that we have on our agenda. The first one are, let's say, blockers, and actually a blocker that we have now with our Elasticsearch engine. That is, like we cannot get it run on our virtual machine for the moment. The problem is the amount of RAM, because for V9 data sets, it's like too big to process. I mean, theoretically, like, according to Brandon, it crashes every time, regardless of parameters chosen, etc. So my proposal is, it's already taught to Brandon. Brandon is not among, it's not today on our call. It's that we are going to our cloud, either to Google Cloud or Amazon servers. We have a lot of credit points. We just buy an instance for a 9 with multiple CPUs with a lot of RAM, so that we can build up Elasticsearch objects with within a couple of hours, something like that, with multiprocessing. So it's my plan. Probably Brandon will need some help, somebody of us. So so I'm going to choose a volunteer to do it with him. And yeah, that's quite simple. Just to write a Docker file, upload data into Docker container on our instance on AWS or on Google Cloud, and build up the index of Elasticsearch. So simple is it. And Imran is coming in. That's first thing. Second thing, just give me a second to search engine. Troubleshooting. Yeah. Okay, that was our trouble for now, at least. Now, task assignments. Once again, please define your tasks or role on the Google Doc sheet in our folder, so that we know who is supposed to who is supposed to do what. And also, please prepare a kind of a short introduction video with shared screen, similar to the presentation Jeremy did for us 2 days ago about Indra, so that people being new in this channel or people being externals can learn very fast what a particular part of this project is supposed to do, so that we don't get over and over again the same questions about a particular library or functionality of it. So it's the second thing. And yeah, and I would like to start some preparation for the first sprint, let's say, a kind of, so that things that are already discussed and clear, so that we can get them working on the virtual machine prepared by Slava. Because and the first thing would be, I think, Elasticsearch. So therefore, once we have Elasticsearch both with on sentence level, section level, and whole document, entire document level, then we can think about like next steps, because actually Elasticsearch is the first preprocessing step for all other steps we already discussed till now. So, and design just intro video already taught. So I think it's everything regarding initial points. Wait a moment, just one person more. So now it's a quick question. Who would be like to volunteer to help Brandon to run Elasticsearch built on the cloud? Imran, do you have something to do? Imran, do you hear me? Okay. Okay, that's so. Let's Imran. Imran. Okay. Let's postpone it. Okay, so that's okay. So now we have also a new person to our team, Sergey. Sergey, are you here? Anton, do you hear me?
Yes, I'm over here.
Hi. You told me that Sergey will be with us. Or...
So I don't see like our other people that were part of that discussion on Slack. So
yeah.
I think we'll just like move that like back to like that conversation back to Slack, and I think Sergey left. So we're good to proceed.
Okay, good. Wait, sorry for me, it's not working. We should send on Slack. Okay, good. So the assignments, it's just I wanted to make clear that we start to be quite strict about it because we need move things forward slowly, but still we need to know who, what, and where is supposed to be. So that's first, second, third. Okay, now because most of the things that has had to be said are already said. So now we can start a bit longer question and answers query, since we have much more time than yesterday.
Hello.
Hello, Imran. Imran, are you?
Yes, sir. I didn't mean to interrupt, Jeremy. I was actually just going to ask if Jeremy could please teach us about what he's trying to do.
Okay. Yeah. Okay. So if you have okay, maybe okay, because it will be, we have something like 20 minutes. So if there is no other question, then Jeremy has something like 20 minutes for a small lecture. That's great. I mean, because we don't have now any other like very hot topics that we need to discuss now. My question is, there are any other questions? Like in terms of organization, in terms of pipeline?
No.
No, okay, so Jeremy, please, you have your 80 minutes.
Okay, thank you very much.
You're welcome. Be my guest.
All right, so let me go ahead and share my screen. And so I'm just trying to think what I want to show first. Go over here, share. All right, let me show you, I guess, first the kind of the overall pipeline here. All right. Okay. All right. So the overall idea is that we want to extract causal statements from the Core-19 literature, represent them in the structured format. So this is subject, predicate, object, and you then there's a condition. There's a cellular context, evidence type, experimental design parameters, additional kind of metadata, and then of course provenance back to the literature from which it came. And then So once we have these causal assertion nanopubs, then we want to be able to validate them. And so that's why Lindsay is on the call right now. She's an expert curator. And the idea is that for those causal assertions that check out, they go into a causal model. For those that are false positives or false negatives or have something else wrong with it, then we go back. Then we use that as training data for the bio-NLP algorithm to do better next time at extracting things. And the idea is that once we've constructed this causal model, this is a static model of what we believe to be the case about host response to virus infection, but it's not static. What we need is dynamic. What we need is data, like time series data, which shows how the host responds, in real time to a virus infection. And so the idea is that we would want to integrate all this kind of dynamic multi-omics measurements of host response to viral infection, and that's what these little dots right here, these colored dots, indicate, is that this is now these the genes and the proteins and basically molecular signatures of known biological processes are being acted. So these are like molecular signatures of known biological processes, and so this way we can still talk about large-scale biological processes, but we have data to support that this process is on or this process is off. And the idea is that by integrating the data with the knowledge, we can perform causal reasoning. And so this is where the probabilistic programming, I think I mentioned Pyro team, is really interested in this. And in fact, today at 7:30 Eastern time, I have a group of Northeastern University students who've been taking this causal machine learning course with me, and they're going to be presenting like a small network, basically addressing the question of acute respiratory distress syndrome caused by coronavirus and potential interventions that medical countermeasures that might be able to reduce the likelihood of the cytokine storm, which is an overreaction to the viral infection. So that's where I'm. So the overall goal is really to predict the determinants of viral pathogenesis and to identify targets for medical countermeasures. And so we've already kind of done that on a small scale already, and we've built some of the infrastructure so that we can take a model. We can take like an arbitrary set of causal statements, assemble them into a network, and then convert that into a causal model that you can integrate with data and perform reasoning with. And so that's the part that I'm working on. And then what I'm hoping that you guys can really help out with is the extraction of these causal statements from the literature as we're continuing to get 1,000 papers a day. It's just way too much for a human being to process. And so I'm really hoping that you guys can help me extract those causal statements from the literature, because there's going to be all sorts of questions. And so some of the questions that I have, I wrote down in the Slack channel, and I'll kind of see if I can summarize it right here. So there are mechanisms that the host employs to detect the virus and initiate an innate immune response. There are also mechanisms that the virus employs to evade the host immune response. We want to be able to capture both of those kinds of mechanisms. There are also, and this is actually a link to a paper that kind of is like a summary of basically all the different ways that, all the different strategies that the viruses, including coronavirus, employs to evade detection. And so being able to extract those kinds of strategies out from the literature would be a really big help. Going back to the Slack channel, there are also mechanisms that the virus uses to shut down protein synthesis in favor of viral protein expression, because that might be another intervention target. There's also mechanisms the virus employs to preserve oxidative phosphorylation cellular activity, so it manages to keep alive. You've got almost got like a zombie cell at this point, but it's still able to produce the kind of energy that the virus needs in order to be able to produce many more copies of itself. And then there's also mechanisms that the virus employs to control apoptosis. If you're not familiar with what that is, programmed cell death. Basically, it's like garbage collection by the cell. And what it does is if it notices that there's a viral infection, then it'll try to, shut itself down so that it can be cleared out by the immune system. But in fact, the virus will block apoptosis and prevent it from being able to shut itself down. Other strategies that happens early in infection. Later on in infection, it may actually want to induce apoptosis so that it can it makes it easy for the virus to escape. And we're not sure. It may be the case that coronavirus uses that strategy, or maybe it doesn't. So as additional information comes in from the literature, we want to be able to quickly add that to our model wherever there are gaps. And so being able to identify what's already known in the literature about these mechanisms and what is missing is going to be really critical in being able to develop a model that can help push that forward.
Maybe there are some questions to Jeremy about it now, like some detail-oriented questions.
I had just a few questions, Jeremy. So when it comes to extracting the nanopub, right? So the assertion, so first we need to extract the triples, right? For the knowledge graph.
Yep.
And then we also need to extract the context.
Right.
Is there any tools that you have come across that we know there's some tools for extracting triples, but for the context specifically?
So that's a good question. What I know for sure is that we have a corpus of these nanopubs where the cellular context is being extracted. I also know that there's a manual corpus where that's already been done. There's also a number of ontologies that make it easy for a computer, so that at least a machine could classify various different papers as to what kind of context is going on according to that ontology. And then the third thing is that there is another group, I believe it's TaskVT, which is specifically focused on obtaining that kind of that kind of context from these papers. And so we should probably be talking with Dan Sosa, who has been managing that effort.
My question would be quite similar to Imran's one, namely, can we build a kind of ontology or some logical graph representation, for instance, for multiple sentences from the same section? So because section is supposed to be some logical unit expressing some high-level idea. So because we try to work with sections or paragraphs embeddings, but being those NLP semantic embeddings, and actually the idea, I think that to express an idea that is carried by a section would be much better with an approach you're working with. So some logical entity relation extraction, but over multiple sentences.
Yeah. That makes a lot of sense. And so it would be really nice to have some kind of story. So actually I can show you. So this figure that I'm showing you right now was extracted directly. So there's and actually, let me just go ahead and go to bio. So that figure that I just showed you is represented currently as these set of Bell statements. Okay. And that Bell statement, let me just go to edit here. Was extracted, that entire pathway was extracted from this sentence right here. Let's see if I can show you a bit more.
This is one single sentence.
No, not one sentence, one paragraph. And so let me just go ahead.
Okay.
Yeah, so it's like a paragraph. It was like and actually let me just go back to the original literature. That might be the easiest thing to do. So that is. IL6 amp. That's it. There it is. Here we go. So that sentence came right from here, and everything that is in that figure comes from this figure. This little figure caption.
Yeah, ideally, it was what it's perfectly 100% what I meant. So a kind of a it's not a section or paragraph embedding, but section logical representation.
Yeah,
Of
it's like a pathway representation.
pathway.
Exactly.
Yeah.
Yeah, so it's a slightly larger unit than a single triple, right?
Yeah. Actually it's a kind of a tree of multiple triples combined together. So like triple is just an triangle, let's say,
Yeah.
and you construct now the whole graph composing of multiple nodes and links, so to say.
Yeah. So it's like a connected component in your graph, right?
Yeah. And
Yeah.
of course, then you can make some Bayesian reasoning upon that, because you can attribute different probability values to each link, to each relationship. Okay, that's easy. I mean, like, we know we are where we are.
So yeah, although I would probably use a structural causal model in this case, because we want to be able to predict the effects of counterfactual queries, which you can't do with a purely probabilistic model. You would have to have a structural causal model, but the idea is exactly the same.
Okay, perfect. We have still something like 5 minutes. And thank you, Jeremy. I mean, like, it's when we have a bit more time next time or over next time, then we can talk further about it, because I think it's very insightful. However, now we need to focus more on things that are like just our next step, because actually and convergence between Elasticsearch, semantic search, and your part is something that we arrive at next week, in 2 weeks, something like that. Now we need to get our tools working properly. So once again, a question: who would like to help Brandon to get Elasticsearch index built up on the cloud or an AWS server? Imran, do you have something to do? I mean, like, I know you have something to do, but would you like to? Would you be eager to help Brandon?
I do not have availability for because you were talking about loading the dense vectors, right?
No. It's I'm talking about just because to get the code of Brandon, to put it in a Docker container, and to carry out the Docker container on AWS or on Google Google Cloud Server on with multiple CPUs, so that we can get the index file or the index object within a couple of hours and not 2 weeks, because actually all attempts by Brandon on our current virtual machine crashed. So it's
what does Lava have for Elasticsearch right now?
like, we cannot build up with Elasticsearch index with the data from V9 version, because we don't have enough RAM on a virtual machine. So the idea is, we have a lot of credit points from Google and from Amazon. We can use it. We can hire or let's buy an instance for a night, and with 40 or 80 CPUs, and run the code Brandon has prepared, so that we can have those objects within.
Lukash,
Yeah.
I think especially because we're missing quite a few other people, let's try to keep this in the Slack, because Pranjalya is not. I don't think he's here. Alex is not here. How
Yeah,
far Brandon is.
but
So
actually, okay.
yeah,
Let's. Yeah. Okay.
there's a spreadsheet, right?
Okay.
So I would hope that we just spend this time discussing more of the roadmap rather than assignments,
Okay.
especially because we don't have everyone here.
Okay. Yeah. Okay. That's okay. You are right to some extent, in the sense that I would like just to remove this first blocker as soon as possible. Therefore, I'm looking for somebody to help Brandon.
Yeah, so right now I know that Alex is helping Brandon, and I could
Okay. Okay.
I could
Alex
get
is
the
with us today? No.
no,
No.
Alex not
Okay.
here. So, and there's Pranjal who's working on triples extraction using Spurt. I think Kevin, who is also not here, is
Yes, but
also doing triples extraction with SemRep.
Imran, I was
So
talking specifically only about Elasticsearch and the problem Brandon has. Just I know that there
okay,
are
yep.
other, yeah, just this thing, because it's first thing that somebody something has crashed and we need to remove it. That's only the only point of mine here. And the rest is 100% agree. We can keep this on Slack running further. Okay, there are any other questions? No? Okay, so I'm preparing an agenda for the next meeting, the same time tomorrow at the same place. If you have any proposal, questions, requirements, wishes, dreams, please drop a line to me. And yep, I think that we can conclude this this meeting.
Thank you very much, Lucas.
I thank you, and yeah, stay healthy, all of
Thanks,
you.
guys.
Thank you.
Bye.
Bye bye.